Welcome back, guys. On our previous video, we introduced this kind of stuff of tree diagram, whereby we talk about the events whereby when you pick something, you don't replace it, what happened, and how to draw a tree diagram. On this video, we're going to take a look at some different example whereby when you pick something, you don't place it back, how to draw that kind of tree diagram, and how to answer the questions of it. So on this example, they say a box contains 4 black and red pens, 3 red pens. A pen is now picked at random and not placed back in the box, So this one is different from the one that they were doing previous. This one, we pick something and we didn't place it back, And then another pen is picked again at random, So it means that this kind of stuff, it has been performed twice, Perfect. So then they say, draw a tree diagram to represent this information. So to draw a tree diagram, now it will be very good example to illustrate using this kind of stuff, So let's say you work on this kind of stuff again, and then you want to know the probability of taking out the black pen here, What will be the probability of taking out the black pen? It will be what? It will be 4 out of 7, So the way you represent it here, we're just going to draw a branch with just this one. This one will be for black, and then you write that kind of probabilities 4 out of 7, And then let's say you come here and you know the probability is 4 over 7, and then you pick this kind of black pen and you don't place it back, You don't place it back and you come again. You want to know the probability now of selecting the black pen. What will be the probability of selecting the black pen when you come again after you've taken that one? It will be 3 out of what? Out of the total number is going to change. It's not longer going to be 7. It's going to be what? It's going to be 6. That's the tricky part here. It's going to be 6. It's going to be 3 out of 6. So the way you represent it in a tree diagram, I'm just going to say something like this. Just going to say for black now is going to be 3 over what? Over 6. Does that make sense? Perfect. We've taken that kind of a ball and we didn't place it back, So when we come for the second time again, since it was the before, and then we take this one and don't place it back, what is the probability of picking out the red pen here after we pick the black pen and we didn't place it back? It's going to be 3 out of 6. Again, even that one is going to be the same as this one for the red one, So for the red one, we have 3 red pens here, and then in total we're going to have 6. It's going to be 3 over what? Over 6. So that kind of stuff makes sense. Perfect. So let's say for the first time when you come here, this time you didn't pick the black ball. You pick what? You pick the red pen. What is the probability of picking the red pen here again? It's going to be 3 red pens that are here. So we're going to represent it like this. This will be red, and it's going to be 3 over what? Over 7, So let's say you work on this one and you pick the red pen, which is this one, and you don't place it back. What will be the probability of selecting the red pen again when you come for the second time? Now it's going to be 2 over what? Over 6 pens that are here. It's not longer going to be 7, and it's no longer going to be 3 because you take the first one and didn't place it back. So you're going to have what? For the red again, is going to be what? Is going to be 2 over what? Over 6. That kind of stuff makes sense. So what is the probability of selecting the black pens after you have taken the okay, let me just put it back so that it can be able to make sense for a lot of you. So for the first time you come here and you select the red pen, which is this one, and you don't place it back. What is the probability of pulling out the black pen for the second time after you select the red? Is going to be 4. This one is not infected, but the thing that has been infected here is the total number of sample space, which is going to be black. So which is going to be, this one is black, and it's going to be what? It's going to be how many? It's going to be 4 out of the total number of sample space. Now it has changed. It's going to be 6. That kind of stuff makes sense. And I've made the mistake. This is red. This is red here, but I hope. But now it's clear. So this is the task that have been performed. So as usual, what we used to do is to connect each and every branch to see where it is leading us. For this one is going to be the same as the last one. Is going to be black, and this one is going to be black and what? And red. And this one is going to be red and what? And black. And this one is going to be red and red. And another thing that I like to do is to calculate the probability of each and every branch there before we answer any questions. It's going to be very, very easy and fast for us to answer the questions, you know. So let's just now calculate the probability of what? Of black and black. You know, so the probability of black and black is going to be what? It's going to be 4 over 7 multiplied by 3 over 6. Remember, guys, when we talk about and, we multiply, you know. Perfect. That's something that you have to understand when we talk about tree diagrams only, you know. Perfect. So then when we multiply all these two, we're going to get what? We're going to get 2 over 7, which is 2 over 7, you know. And then now we want to know the probability of black and red, which is black and red. This one, for black, it is 4 over 7, and for the red, multiplied by 3 over 6. It's going to be still the same thing. It's going to be 2 over 7. And now we want to know the probability of red and black. This one is going to be different. It's going to be 3 over 7 multiplied by 4 over 6. And for this one, you're going to get, again, it's still the same thing. One of we're going to get 2 over 7. I don't know why. And then for this one, the probability of red and red is going to be what? It's going to be 3 over 7 multiplied by 2 over 6, which this one is going to give you 1 over 7, you know. So when you calculate all this kind of probability, it's going to be very, very easy for you to answer any questions that is there, you know. So now let's go and look at our questions, you know. So our question, the first question says that what is the probability that both pens will be red, you know. We want to know the probability that both pens will be red. I will write it here so that it can be very, let me just write it here so that I can be able to, yeah. They want to know the probability that both of those kinds of pens will be red. So then red is this one, you know. So what is the probability of R and R? This is number what? It's number 2, you know. So this is number 2. So this one is what? For number 1. For red and red, we already calculated it here, is 1 over 7. So when you calculate this kind of stuff before answering the question, it's going to be very, very easy for you, you know. So then they say, what is the probability that the first pen will be that the first that will be picked will be black and the second one will be red? So you have to understand, yeah, they just give you the command that the first pen, it has to be black and the second one will be red. So let's just go and look at our branches here. Which one is the first black and the second one is the red? So the one that is the first black and red is this one. So now we're going to just write that kind of probability. So then this one is the same as the one they're asking for, the probability of black and for what? For the red. Pay attention to this one. They didn't say the one that is black or red, you know. So if they say for like the same way of our last question, whereby they say they want the probability of the one that is black or red, we'll just take these two. But for this one, they specify, they say they need a black and the second one will be red, you know, so which is that one, and the probability is going to be what? 2 over 7. Does that make sense? Perfect. So what is the probability that one pen is black and the other one is red, you know? So look at this one. They say that one pen, you know, one pen is red and the other one is one pen is black and the other one is red. So for this one, they didn't specify that the first one must be what, the second one must be what. They just say that they just want a probability of each and every branch that is what, one pen that is black and one pen that is red, you know. So this one there's black and red, and this one is a black and red, you know. So they want to know the probability of these two. And remember, this is the same as when they're looking for the probability of BR or of what, of RB, you know. Perfect. Because what they say, the probability of one black or and another red, actually, you know. So when we talk about OR, I told you on my previous video, when we talk about OR is equal to what? 2 plus. Here, when we're dealing with the tree diagrams only, you know. So we're going to look for the probability of BR. We already calculated it here, is this one, which is 2 over 7. Plus, now we're not going to multiply. Be very careful. We're going to plus this kind of stuff. And for the one of RB, which is 2 over over 7 is the same as that one, you know. So this one is going to give us 4 over 7, guys. So this is the end of this video, but I promise you on my next videos I'm going to do some more example about this kind of tree diagram, because I'm until you understand. So see you in my next video. Sharp.